morning.
Good morning.
You start to analyze your result now.
Haven't you?
Okay. The topic of my talk today is on what your survey says and how to report the findings. That means by now you should have corrected your result, your survey or interview or whatever, and you're supposed to start to do the analysis now. Alright, so I presume this is the status you are in now. So generally, we can say that your survey either you fall into the quantitative or qualitative study, but in fact the differentiations is not so clear. You understand what I mean or not? For example, a lot of people make it like saying that interview means quantitative. Interview means qualitative. You conduct a questionnaire survey means quantitative. Actually, it's not that clear. Honestly speaking, most of the time, all the research by the management student, management is a social science, so generally supposed to be qualitative. Even you are asking the question, you ask the people to answer 1, 2, 3, 4, 5. It's all qualitative. It's not quantitative. Quantitative, it is something like probably you conduct a lab experiment. You want to detect the concrete cube, the result, all those things, those are quantitative. So generally, most of the time it's a qualitative. But anyway, that's my interpretation. It's up to you. Your supervisor might tell you different story. Okay. Now for the research, generally you ask a lot of questions, especially whether you are doing the interview or questionnaire. But if you have a well thought about your questionnaire, then you should know that whether you are conducting a study, whether you want to study something, you want to find out something descriptive, or something you want to find out whether there's a relationship between A and B. Those are called association. And probably you want to study, even let's say between A, different people have a very significant difference in interpreting something. So therefore your research question is supposed to fall under one of these categories, whether different associations or whether it is descriptive. If you cannot find, then some problem in your study, I would say. So if you cannot identify that. Now, example of a descriptive is, for example, you ask, what is the digital maturity level of quantity surveyor? So you just want to answer something on this. So therefore you set some of the question on the different maturity level in order to determine that. If your question is something about difference, for example, does the age of the quantity surveyor make a difference on digital culture in the construction industry? So you want to find out different age, whether there are differences or not. So that is the reason why your questionnaire, you have biodata. Because a lot of time, a lot of students, when they carry out the study, that's why I always tell the students, the questionnaire is the most difficult thing to set up the questionnaire. If you didn't really thought about it, you just see that you have to answer a lot of questionnaire, then you know how to ask a question, you just set a lot of questions. At the end, you don't know what you are analyzing. you don't know how to interpret. So therefore, the questionnaire, for my record, sometimes my student even up to week 7 also cannot settle. Alright, I'm very strict on that. So before you set up the questionnaire, so it's not a matter of 1 week, 2 weeks. Once you meet your lecturer once or 2 times, then you can settle. Alright, so if you are able to do that, I would say that you are very smart student and your lecturer are very efficient as well. Alright. Now, lastly, like whether the digital culture have a relationship with the success of an organization or not. So this is an association question. That means you try to find out the relationship between the organization's digital culture and the organization's success. So only with this full thought of what you want to find out, what you want to study, then only you can have a smooth interpretation, analyze the result, etc. The research questions, just like I mentioned, there are 3 types of research questions. So that is either is a different research question, associations, or either is a descriptive. Because once you determine this, then only it becomes your subsequent hypothesis testing. Like for example, you're doing t-test and no-one test, especially most of your, because you here say that must use the SPSS, so you use the SPSS, you got a very good score. But then I tell you, not necessarily you use the SPSS, you can get a very good score. For my marking standard is, I will ask the students whether you really know what you are doing or not. So, to me, I will look at it very different. You show me a lot of things, so whether you understand what you are doing. You don't know what you are doing, that means you don't have a full understanding of the reason behind why you do all this. So, it could be you are not getting a good grade also. Alright? There's no point, it's no point you see somebody are doing, so you just follow. Very basic is you have to understand what you are doing. So that's why whether you use a t-test, so the t-test what you want to show actually. You want to use the global alpha reliability test, what you want to show. Yeah. So that's why to me, when I guide my students, I want the student, to write the method of the study, rather than you tell me Spearman, global alpha, all this, you try to use some mean. You think that by putting such a mean, that means it shows that you have a standard. No, you can't cheat me like that. Okay? You cannot simply tell me that you are using a method used by Robert King. Robert King are very famous in the Robert King are very famous on qualitative research. But just with the Robert King not good enough. Robert King's what? And in what circumstances Robert King say that? So if without that you just tell me Robert King, so what? You don't know at all. Alright? So like for example, that's why I show you over here. Once you are doing your hypothesis testing, which test you need to do is you have to understand the nature of your research question. Then only you can choose the appropriate method. Okay? And move on. So for those like difference association, this kind of analysis we call this influential statistic, and the other one we call this as a descriptive statistic. Descriptive statistic is something like mean, average, Even like for example, a lot of y'all like to use the relative important index. later I will tell you actually that means nothing. If you use a relative important index and average, mean nothing. It's the same thing. They are the same thing. I'll show you later. So all these are descriptive. Descriptive means, for example, if I have questions, let's say I want to test, I just choose a 1, 2, 3, 4, okay, to answer some of my questions. Then after that, all of you, 4 of you have answered my questions. So then, whatever the result show actually is only represent 4 of you only, nothing to do with the rest. But actually, more important is, I come here, I not just teach 1, 2, 3, 4. So, I want to know the population, that is the full class, whether they understand me or not, etc. So therefore, if I cannot do a detailed analysis on the full class, at least I have to choose the sample. And then with that sample, I have to go through with a very rigorous analysis, statistic analysis, so that the sample I choose, at least I can very confidently and say that the whole class, their performance will similar to what I have done, even though I choose a sample. You understand what I mean or not? So if you are not using inferential statistics, generally, whatever finding you have, you cannot draw conclusion. That means you cannot generalize. You can just say that, like just now I say, I conduct a test on 1, 2, 3, 4. So my result is just represent this 4 students, not the full population. Research is meaningless if you cannot generalize. You get what I mean? Having said that, I don't know how is your performance, academic performance, etc. But do not feel very stressful. Even let's say, if you are doing a very good descriptive statistics, no reason you will feel. You get what I mean? But if you need to have a better grade, then inferential statistics is mandatory. It's compulsory. You should have, because otherwise your research are meaningless. You get what I mean? Now, so I repeat, for statistics, we have a descriptive statistic and inferential statistic. Descriptive statistics are very simple. So you do mean, average, ranking, ranking. Just now I say, most of the students are doing so-called the relative important index. Then inferential statistics is, we have 2 categories. One is for you to find out difference. The other one is to find out some associations between the different variables. Okay. I have explained this in quite detail over the other 2 slides. I'll skip this one. Now, for example, a typical descriptive sort of thing is, I think most of the time you ask a lot of bio data. In fact, most of the time, the students' questionnaire are better in bio data than the actual research questions, because there are so many samples. And after you have get that, so how do you analyze? I mean, how do you present your data? So, I always see the student with male and female draw a table. After a table, there is a full paragraph of description saying that so many male, so many female. Then add another pie chart or another graph. Okay, so all those kind of things. Every month, one by one, showing all those bio data. Actually, this is only your high school standard. Sorry to say that, there is only high school standard only. Alright, like for example, the presentation here. So, with one paragraph, one table, actually reported what all the important facts about your respondents. You understand what I try to say or not? So to most of the time, the student might spend 1 page, 2 page, 3 page, 4 page on the same information. Alright? Okay. Now, my question is, if you were the examiner, how do you grade this presentation? Nice or not? Looks very nice. There's a paragraph, there's a table, there's a chart. Color some more. But you go to the same thing. To me, it's a one sentence copy already. You get what I mean? Now, because I tell you, I have to admit that the project, research project, different lecturer because of their big background. So the way of evaluation are very different. You'll be surprised if I tell you these are from one of the grade A center. Alright? But that's why don't look at those samples. Try to find out exactly what you require factor. Alright? Now, what about this? Okay. Have you thought about how to improve the presentation of this paper? So, you see most of the times, let's say you have used SPSS or something like that, very commonly for the student, just a cut and paste of the paper. Very easy man. But actually, number one, you're not supposed to cut and paste. You're supposed to present your own result in your own format. So therefore, how to improve this paper? Can anyone suggest? No? No, I have to go faster. I got 60 slides. I don't want to waste time on that. So number one, do you see the number 62? All are the same. First of all, you show one column, 62. You get what I mean now? You can already put it in your title. Your number of respondent is 62. So you save the column. You get what I mean now? But not only that, you look at this figure. You look at this figure. So if you want to see which one are higher, which one are lower, you spend time to look at it. Correct or not? You understand what I mean or not? This is highest, this is a second, this is a third, etc. When you want to analyze, when you want to present the paper, so you have this problem. So nobody stop you to do such thing. You can always rearrange. You get what I mean, from the highest to the lowest, easy to see. Then you don't need to have later I have an example. A lot of students add another column ranking 1, 2, 3, 4, jumping here and there. But that makes your readers difficult to read. So when you present something, when you write something, try to make it convenient, easy for people to understand. Alright, so you see, I rearrange this, then I know this is higher, this is second, etc. And how I show the 62, I put it here. And this is the total number of respondents. You got it? How about this? Again, very conveniently, probably you have a certain data, you use your Excel, etc. So then it draw the chart for you, something like that. Do you feel that these charts are easy to read? Yes or no?
No.
So, you see, when you read, you want to know, this higher, this second, third, etc. As again, you have to spend the time to look at all this. So why don't we present, a better way? You get what I mean? So all these are the, your presentation skill. How to improve your presentation, and do not limited by you only, it seems like you can only follow this order. Not necessary. Very flexible. So think about how to present your result. Okay, now I want to come to the difficult part. So if, let's say, you are aiming something like, I'm not saying aiming. Let's say you feel very stressful on your project. So do a very good descriptive analysis, like what I said, including your presentation, like what I show you. So try to take care about all this good enough already. If you want to go a step further, to use a SPSS or whatever to analyze your result, then you better understand what you are doing. Okay? First of all, when we use a SPSS, I think probably you always hear that, oh, I have to look at the figure less than 0.05. You know, so only show the result is significant. Why? What is that? Can you understand or not? Do you know that or not? Oh, less than 0.05. I can include that in my report, in my writing, etc. So generally, that is a problem. What we have. First of all, you see, for those students, they don't understand the research. Even they done descriptive statistics. Descriptive, you know what I mean? For example, you rank the student performance now or something like that. You do your RIR or this. They have their mindset. They're thinking that, oh, that is the result. That is always is like that. But it's not. Actually, I told you it's 1, 2, 3, 4. You know, it's not the whole population. Alright. When you use when we are doing the inferential statistics, even you are doing inferential statistics, you are moving one step further. You go more detailed, but you can only say that at 95% confidence level, at 95%, not 100%. But for those doing the descriptive statistics, they never thought about it. They never done that. They may think that that is the whole picture. You follow what I mean or not? So while you are using inferential statistics, you can only confidently say that my result is 95% correct only. Probably there are 5%, it won't be 4 as what I have found out. So that is the inferential statistic. And then you might tell me, then can we do higher level, 95 only? Can we do higher? Yes, you can do 99. Okay, you can even do 99% level. Okay, but the problem is, 95% also difficult to find already. Some of you have done so much hard work and at the end cannot find anything significant. Alright? So don't get through and think that 95 I want to do 99. Yes, 99 you can do. But why 99? Cannot do 100%? No, you can't do 100%. Nobody knows. 100% only God knows. So statistics cannot prove 100%. The most are 99.97, 99.99999. You can never time 100%. The reason is because you just imagine our statistics are something like that. This line and the horizontal line. You have this curve and horizontal line. They go to infinity. They will never meet. When they meet, they can never meet. Even how you go on, it only increase the 99% only, but you will never reach 100%. Okay, that is behind the statistic. But generally, it's good enough if you can have something like 95%. It's good enough you have something like 95%. 95% is 1.96. That means you are having something like 2 standard deviations. Now another thing is when you are carrying out when you are using the statistic, the SPSS, the software, not necessarily SPSS, you can use SAS, you can use R. If you know how to do it, you can even use Excel. Alright? SPSS is just the most popular software, that's all I mean. Excel also can do that if you know all the functions. Now, if you are using all this, you are carrying out, just like I mentioned, is inferential statistic. Inferential statistic is built up on the foundation of you are testing a hypothesis. You make a hypothesis testing. What is hypothesis? It means you make a case. You try to say that case are not that to prove that whether whatever you propose whether is correct or not correct. But again, whatever you propose under statistics is like that. Listen carefully. This is a big difficult part. This part are very difficult to understand. When you carry out the hypothesis testing, hypothesis, that means you imagine something. Okay? So whatever you imagine, it could be come out to be true, or it could be come out to be untrue. Correct? You are using some medium to test something. You need to ask some questions so that you can end up with a conclusion of something. There's a few possibilities there is an error. Number one, the question you set whether appropriate or not. The option you give to the respondent to answer whether correct or not. You get what I mean? The skill of measurement whether correct or not. So that's why it's not easy to prove whether the hypothesis is true or not. Then secondly, you say that with this test 95% confidence. So what about the 5%? It could end up because there's a 5% definitely is an error. Okay, so there's a 5% over there. So therefore, generally, there are four possibilities here. A square, something like that. A four possibility. So even with the four possibility here, which you are only looking at this part of it, the correct decision. Even you have end up with this correct decisions, you see the situation or something like that. Let's say your hypothesis is true. This is your alternative hypothesis is true. But normally when we test, we use a not hypothesis. HO we call it not hypothesis. That means not hypothesis is true or not hypothesis is false. Alright? Then over here, either your decision is you accept whatever you tested or you reject whatever you tested. Okay, so there are four possibilities, and then between the four possibilities, two are correct answers. One correct answer is whatever test, you pass your less 0.005 or the other thing. But there is one quarter only, the another 3 quarters. The other 3 quarters totally is not true. But then there's another quarter. Actually, that is determined by the 95%. Because you prove 95% only, so therefore, what happens to the other 5%? Alright, so if you feel difficult to understand the concept, now we use some legal issue. Alright, there's something like legal scenario. So when somebody are being judged in the court, it could be the person is guilty because he really do it, and then the judge made the right decision. So therefore, it is a guilty and justly convicted. You understand what I mean? But another situation is the good situation is the criminal really is innocent. Okay, so for the criminal is innocent, and the decision is not guilty because he never do it, not guilty, man. So this one he do it, guilty, man. So this is a correct decision. But we can have another two situation. The situation is It is a guilty, but not sufficient evidence. So therefore, the fellow walk off from the court. It's a guilty, but you don't have sufficient evidence. This one is, he is a innocent, but you put him in the jail. You get what I mean? So these are the four possibilities. But actually, for when we have carried out the study, we only look at this part only. We don't consider this part yet for the hypothesis testing. I mean for the study what we are doing. Now, how you carry out the hypothesis testing? You see, for example, this is an example. Customer service training of IT telephone support staff will not lead to a significant improvement in user satisfaction feedback. Now, most important is when you set up the hypothesis and not hypothesis is with the word not. You have two variables here, variable 1, variable 2. So you say that variable 1 not cause variable 2. This is called not hypothesis. But your objective, I mean your original statement is supposed to be this one. We call this alternative hypothesis. In other words, when you set up your hypothesis, you try to set up a statement which is opposite of your research question. You understand what I mean? For example, this one, actually the study is you want to find out customer service training of IT telephone support staff will, I missed out something, will lead to a significant improvement in user satisfaction feedback. So actually you want to prove this, but he want to prove this statement. So how to prove this statement? He can only prove that this statement, he rejected this statement, then only can prove this. That means if I'm able to reject, I can able to reject this, that means this is true. So in other words, in your analysis, I mean when you carry out your statistic analysis, when you get the figure more than 0.05, the result is you reject. That means statistically significant for you to reject your result. Why you reject your result? Okay, come back here. You remember this graph? Okay, let's say this part, this area and this area add up. The whole area is 1. I will prefer, if you are not listening, please go up. Alright? Because I can't focus. It's no point you sit here, you have your own meeting. If you are here, you better give your time to me. Alright? Otherwise, I will keep on stop. Alright? We only have 2 hours, probably not enough. I told you I have 16 hours. Okay? If you want to talk, I will stop. When you talk, I stop. When you talk, I stop. Then end up I finish 20 slides. Alright? There's no point I continue. Okay? Now, just now I mentioned, actually it's because of this glass. So, this part and this part, you imagine the whole curve and the horizontal axis, when they go to the infinitive, imagine the area is 1 unit. So therefore, this part and this part actually is 0.05. You get what I mean? That is a 95%. This is a 0.05. If you imagine the whole area is 1. So the moment you have this figure greater than 0.05, that means that go inside. They come inside. So do you still have 0.95?
Yes.
You still have a 0.95 when they come inside? This one is 0.95. originally, here to here is 0.95. But when this figure you get inside, do you still have 0.95? No. Okay, so that's why, that is the reason why when you see the figure more than 0.05, you have to reject. You reject what? Reject the hypothesis. And reject the not hypothesis. And the not hypothesis actually is the opposite of the question you want. So therefore, statistically, I can prove that there's a 95% chances my original statements are true. So that is the concept behind why you use, why you use not hypothesis or this thing. All right. It will be only meaningful if you use this, you write this in your report and you really understand what it is. So, where the probability is less than or equal to 0.05, this indicates that the alternative hypothesis is likely to be true. That means this is your original proposition is true. And one can never prove the not hypothesis is correct. What does it mean? That means if you get any figure more than 0.05, you can only say that I fail to prove, or the result fail to reject the not hypothesis. You cannot say that the result has, because the results are more than 0.05, so therefore I can prove that the not hypothesis is correct. Not hypothesis not necessarily correct. Why? If you go back to this example, that means you have not sufficient evidence to reject. You cannot, that means you don't have sufficient evidence to prove that the person is guilty. You don't have sufficient evidence. So, if you don't have sufficient evidence to prove that he is guilty, yet you say that you put the person in the jail. Correct or not? So it's not correct. So therefore this must be very important. Again, there are some grade A sample showing, I'll show you later some of the not correct interpretation. One can never prove the not hypothesis is correct. And if you fail to reject the not hypothesis, you can only conclude that there is insufficient evidence to warrant its rejection. So therefore, if you fail, you can only say that you don't have sufficient evidence. You cannot conclude the opposite. So that's why I say this part are very tricky. You really need to think about it carefully. So, what is not hypothesis? Not hypothesis is a hypothesis set up to be rejected. You get what I mean? Why you write a not hypothesis? Actually, the moment you write a hypothesis to carry out this research, your purpose is you want this hypothesis to be rejected. You get what I mean? The moment it gets rejected, boy, celebrate. The moment you cannot reject it, then you cry. You get what I mean or not? So you have to get it rejected, that really means meaningful. There's no significant difference between the group. So again, because for example, what you want to find out, for example, if I want to find out whether the female QS graduate and the male graduate are they performed differently? Are they more successful if I want to find out between the gender? So therefore, the first thing is, my statement is, my research question is, probably there is a difference between male and female. Okay? There is a difference. I want to prove this. So therefore, I carry out this research. After I collect the questionnaire, I analyze, my questionnaire is, I want to reject there's a no difference. Once I reject there's a no difference between male and female, I can conclude that there is a difference. Okay, you try to reject there's a no difference. Okay, but if you feel to reject, then it is 0.05. If you feel to reject, does it mean that there is a no difference? It's not necessary, you know. So you can only say that it's the other one. There is a, you know, your original. You didn't prove this one. So therefore, don't make a conclusion based on your null hypothesis. So if the theory allows us to have a fit in the alternative hypothesis that is generated in particular research investigation. If you remember my just now my matrix, so actually we are only taking the other half only. So the other half actually is based on 95%, 99%, those are power. So we assume that there's no problem over here. And you recognize that there is a 95% only. So you look at one part only to make a conclusion. Alright? Now for example, this is from one of the A sample. My comment because the lecturer has treated this as an A. Alright? That's why that is my comment only. I would say it's wrong. You see the way of writing. Do you think there's a problem here? Kruka-Valley test is carried out to investigate where there's a significant difference between the opinion. Okay, there's a significant difference between the opinion of the three different income groups involving respondent income. With detailed observation, it is evidence that there are no significant difference. That means the figure are more than 0.05 among the different income group on all 18 features of TOD. This means that the respondents are consistent on their perspective on this. So actually, the hypothesis is set up to reject. There's a no difference. But then, if you to reject, can you conclude that there is a difference? So you can only say that if you, because of your test, you fail to prove this. But probably there is. Then you need to carry out other tests. Or probably your questionnaire are not good enough. You cannot say that that's no good. You get what I mean? Is it fair that, you know, to you, let's say I set a question, I'm your lecturer, I set a question, and based on that question, I mark you wrong. Okay, I will test you on one of the area only, but then I mark you wrong. Then you bring that because you mark me wrong, you mark me wrong. So actually, it proves that I have the knowledge of the subject. Cannot. If you have a topic, let's say 10 topic, I set a question, topic 5 for example, and then your answer is correct. But I mark you wrong. And then actually your answer is correct. You prove that your answer is correct. Then you claim that I have a knowledge from 1 to 10 because you mark me wrong. You follow what I mean or not? Actually what you can prove is only the question topic 5 only. It doesn't mean that you have a knowledge from 1 to 4, 6 to 10. You understand what I mean or not? You cannot generalize like that. So this is having the problem, something like that. Again, this is another example. Is all these statistically not proof significant, but the conclusion right that this means that the respondent have a uniform saying in reading the benefit, and worse is this part. This shows that household income has no influence to both the benefit of TOD. Malaysia do the same regardless of each income group they were in. So you see, this is a very confidently and jump to the conclusion because he feel that, and then he conclude this is the truth. So that actually is one of the biggest problems. If you don't understand the statistics, Now then, this table actually is just depend on your questions, etc. What are the tests to choose? Because if you use SPSS, then you found that there are many tests. So which to choose? So this table provide you with some good information on that. Now again, now I want to continue with some more sample. I prepare to spend 1 hour on quantitative, another hour on quantitative. Alright, I left 10 minutes only, I have to move faster. So for example, comparison of perceptual activity of assessment or this thing. So this is one of the way you can show your result. So in this case, actually you notice that for this one, there's only one answer, there's a significant only. You get what I mean? On the other 1, 2, 3, 4, 5, 6. Out of 6 category of GPI, only one is a significant only. Alright, that it shows that there is a difference. So you see, what does it mean by statistically significant? Now, when you look at all these score, I always use the word 盲的不知道. You look at it, the figure are different. The different are different. But that is statistically it can represent the population or not. So therefore we have to look at this figure. So once it become for example here, you know that all the figures are different. So 0.52, what does it mean? That means they are somewhere here. So the most you can say that 58% of your result are like that. Then can you make a conclusion? Because 0.52 no, 48%. 52% are not correct. 48% are correct. And you base on 48% to make a conclusion. Correct or not? Then, for example, if you are using a correlation, okay, correlation, it will show you something symmetric, and then the data are actually, like 3.26, 0.326, 0.236. This is one. This is a mirror image. It's having the mirror image. So if you are using this you cut and paste this, then actually it's difficult to read. Number one, there's so many data, etc. So how to present when you are doing the correlation? So probably you can present something like that. You relook of the data, so then only you present this. So rather than the full table. Alright, so this is number 62. Now I want to show you why the relative importance index are nothing. Alright, now can you see here the mean, blah 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 blah. Then if you are using this, okay, so for example, sometimes people are looking at this, then because it's difficult to read, so therefore you add another column, so-called rank. Rank is help you, direct you to this, 1, this, 2, this, 3, this, 4, this, 5. But just now my earlier method, I show you that I save a column, okay, then yet very clear, I can see. You get what I mean or not? So therefore, I don't need the last column, and actually if I ran this, then it will be the same. And this column, I can save. I don't need to have this column. You understand what I mean? The last column, I can delete. Now, this is one example also, so-called, now exactly this is important index. Okay, so-called you use a very funny formula, but actually, after you study your Excel, you meet thousands of formulas. So what is that formula? Someone want to put the author from so and so. In your development appraisal, you have created so many formulas. Do you go and patent all your formula? So it's a nonsense to me. You have that formula. Now, you see that this is important index. Actually, how to improve? Now, first of all, if you look at this figure, this 4.22, this is 0.844, this 3.39, this 0.67. You get what I mean? Huh? You follow what I mean? Huh? All these figures correspondingly actually is a multiple of your average. So that's why I say your mean are good enough already. If based on this table, the relationship is you use this figure times 2 divided by 10. All the figure times 2 divided by 10, you get the same figure. And you don't have to worry about the S1 plus multiply N1 plus S2 multiply N2 plus blah blah blah, then divide by blah blah blah. Look complicated only. 骗人的. It's so simple. And the beautiful part is, if you know how to use SPSS, you just over here, you choose whether you want the number go decreasingly or increasingly. That's all. You don't need to rearrange yourself. And after you click this, it gives you very nicely. You understand what I mean? You don't even think. Don't even need to think, but which is no good. So therefore, AI replace all the human brain. Then again, this is what I want to try to show you is the way of a presentation your information. For example, if I have a long table like that, I have a data, I have a percentage. Rather than I put at the side, can I put something like that? You get what I mean? So therefore, when I read this figure, I'm reading the figure. The second column, I only read the percentage. So therefore, I can read the figure more easily. But up to you. If you think that this is not good enough, it's up to you. Then again, the next thing is how to write. How to write. If you have a test already, how to write. So, like for example here, you don't need to describe one by one. So like here you say, let's say I use a Freeman test. Freeman test was used to compare 202. Okay? Respondents' habit in using plastic or reusable bags during shopping. The results show that the difference of using plastic and reusable bags during shopping at different places is statistically significant. Why I say statistically significant? Because the chi-square 53.155, and not because of the chi-square, actually it's because of the p-value. Asymptotic significant is a p-value 0.002. And then I use a plastic bag wherever I shop. Is the rent higher. So over here we use a mean rent. However, I bring along suitable reusable bag. Supposed to be reusable bag. Typo again. When I shop at wet market, rank the lowest 2.11. So this is how you report the result. Again, let's say this one, you conduct another test called Kruger-Wallis. Kruger-Wallis, you look at the different age group. So Kruger-Wallis test was used to compare 173. Why 173? Is from here total respondent habit in using plastic bag. The results show that the difference of use of plastic bag whenever shopping. Actually, I only analyze this one only. Is statistically significant. How do I know statistically significant? Because I look at here. Okay, the figure are 0.07, which are less than 0.05. Then I can further comment that the age group of 18 to 24 rank highest 114, and then the age group 45 to 54 is least using. What does it mean? This is a true case that a survey done by one of my master students on using plastic bag. She studied something on sustainable development. So you can find that don't disrespect, don't look down at the old people. Senior people like me, okay, we are more concerned with a sustainable development. But the lowest younger group, they tend still like to use a plastic bag when they go shopping. But for the older generation, they always bring the recycle bag. Right? Now, then of course, the research, I think generally, if you can done a very good research until this stage, I would say that you have done a very good research already on Mitofor. It's already on Mitofor already, very good research already. But actually you can go a step further. Because for example, when I say this figure, for example, you look at the different group. So you can rank them, you know, which one higher, which one lower, etc. But then does it mean that, you know, this group and this group, they are different, you know, they are very significant. For example, this group only have a 2 number of respondents only. So therefore, you have a group there. What you have proved is A, B, how many groups? 1, 2, 3, 4, 5. 5 groups, A, B, C, D, E. What you can prove there is generally A, B, C, D, E is different. But can you say that A greater than B, A greater than C, A greater than D, A greater than E? Or can you prove that B smaller than C, or B smaller than D, B smaller than E? Or can you say that C and E relation? Or can you say that D and E relation? You don't know yet. You haven't proved yet. So therefore, if you go further step, again, SPSS. So let's say D is the first test. That's a null hypothesis. Okay. Then you press this, reject the null hypothesis, then it give you the breakdown. Okay, continue. That means the first group and second group, first group and second group, etc. Then after this result, just now you see overall is significant. But now, after there are so many things, then only you found that it's between this group only. That means it's only between this group, the 19 and the 26 group, there's a difference only. So the rest you fail to prove there's any significant difference. This is when you want to go further step now. But I think whatever I said earlier already make you difficult enough already, isn't it? Worry enough already. So don't stretch you so much. Now, okay, 4 minutes past 10. There's a short quiz here. Just take your phone and then answer those multiple choice questions. I take the opportunity to take a short break. After that, I continue the quantitative.